All right, so it's your old pal, Mr. Cook. We're working on the Unit 5 test review, and we're going to do a whole video on number 5 here. So 5 is difficult because it requires a lot of like kind of prerequisite knowledge. Number one, you need to know that an arithmetic sequence basically works like a linear equation, like y equals mx plus b, because it keeps adding the same amount. That's what a linear equation does. And then you also need to know that the common difference, the d value, is basically like the slope. And on top of that, you need to know the slope formula. So the slope formula is m is equal to y2 minus y1 over x2 minus x1, okay? So to find the common difference, it's like this, and you just need to extract the coordinates from these two values. So like think of the little subscript values, like 12 and 40 as your x values in a coordinate, and then the y values are what it's equal to. So that's like one coordinate, this is another coordinate. Then to find the common difference, you just do the slope formula. So it'd be the y2 value, 110, minus y1, 54. And then the x value that goes with it, it goes below it, so 40 minus 12. So let me just, calculate this out. So 110 minus 54, that's 56, yeah. And then 40 minus 12 is 28. 56 divided by 28 is 2. So that gives us the common difference, 2. So when you're writing up the explicit formula for an arithmetic sequence, you need the first term and the common difference. We have the common difference. We need to find the first term. So there are a couple different ways that you can do it. One way is a really easy way, and that's to just plug it into the formula that you have. So an equals a1 plus d times n minus 1. So we have the common difference already, that's 2. We need the first term, and actually we are given an n and an an value in each of these coordinates. So I'm going to plug in 12 for n, and 54 for an. This is really, really similar to how you would solve the y equals mx plus b problems back in algebra when you were given a slope and a coordinate. It's like basically the same steps. So let's solve for that a1 value. So 12 minus 1 is 11. 2 times 11 is 22. If I subtract 22 from both sides, I get 32. All right, so a1 is equal to 32. So I just plug that into my formula over here. So an is equal to 32 plus 2 times n minus 1. And then, you can distribute the 2 in there to, complete it if you want. 32 plus 2n minus 2. And then subtract 2 from both sides, you get an. Combining like terms, subtract 2, so you get 30 plus 2n. So this equation is the same as this one. You can get it that way. Another way that you can get it if you are just lost on all this. I know all you can do this part where you get the common difference pretty easily, But in getting that first term, it might be difficult for you. So here's kind of like a jailbreak way of doing it. You know that the 12th term is 54. So let's say that's the 12th term. You can use the common difference of 2 to count backwards to get to the first term. So like the 11th term, to get to this one, I had to add 2. So to get back, I need to subtract 2. So 54 minus 2 is 52. Gosh, excuse me. And then just keep subtracting, 2 to get to the desired term that you want. So let's count down to the first term. So 8, 7, 6, 5, 4, 3, 2, 1. The first term should end up being 32. Let's prove that that's the case. So if I subtract 2 again, 50, subtract 2, 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 subtract 2. See, I get 32 for the first term, just like what I got over here. So, you can get it that way as well if the term number is small enough. That's kind of an easy way to get it. So yeah, that's this problem. I think I've spent enough time working on this one, so I'm going to stop here, and then we're going to take a look at the geometric problems. Looks like I'll probably end up doing the next 4 before I get to series. Yeah, so that's what I'll do. All right, that's it for this one. On to the next video.